All right, guys. So I want to just quickly discuss pausing and unpausing the view. Now, Metal is special in its API in that when it pauses, um, it's one of the only APIs where you literally pause one frame and you just keep displaying that frame. But most importantly, because you just keep displaying that one frame, the CPU and GPU can go idle, right? So you're not consuming energy, you're not consuming compute, you're not consuming resources. You're basically sitting idle when the frame is paused, right? Now, obviously, once we start updating the frame, because of course the triangle is rotating, then obviously the GPU and CPU and stuff has to do what it's doing, right? But it's one of the it's why Metal is known to be efficient in its approach, because in other APIs, even if you pause this frame, it's still the GPU is still drawing new frames and displaying to the screen, right? So even though it's paused here, the GPU is still working to display these new frames, which shows a still picture, right? But in Metal, you basically freeze that one frame, and that's it. Now, of course, there's a display component, which, of course, the display still has to keep running. So the display is a different conversation, but because we still have to see that one frame. So that's the display side of things. But as far as the GPU and CPU and the Metal API running and stuff, when the frame is paused, that's an opportunity for a lot of resource savings, efficiency, power efficiency, etc., etc. This is also a knockoff of what happens when, let's say, the window is out of view. So let's say Metal knows that the window is not viewable. So if I were to hide this window behind this window here, and the entirety of the window was not viewable, basically, from what I understand, Metal will just not stop rendering, right? Because obviously, if no one can see what's going on in the window, then you know it doesn't make sense to be wasting time to generate frames and all that stuff, right? So that's sort of a knockoff of that. But anyway, so what I wanted to show is just the analytics. This is Metal Trace, the analytics behind it. Now, it's a little bit rough because I was hoping the GPU would show like complete idle, but it doesn't. Um, that's a long conversation. But anyway, we do see Metal application encoder time. So this is the encoders basically going silent, right? But this is more of a CPU thing. The encoder is going silent because, of course, we have to encode this stuff and submit the command buffers and all that. So that goes silent. We could see CPU usage is kind of paralleling with the encoder, and then it goes. But we're about GPU programming and stuff. But one of the other things that I wanted to show you, so it's not perfect, but one of the other things I wanted to show you was that the drawable present and drawable presented. So in a previous episode of of our explanation of this project, we said that a frame can be drawn but not necessarily presented to the screen, right? So we could draw a frame, but it hasn't yet been presented to the screen, right? And this dynamic right here shows exactly that, where we have a drawable present and then drawable presented to the screen. Now you could kind of see, if you pay close attention, there's a little bit of a delay between the present and presented, right? So that shows you that, yeah, we drew the frame, but we haven't presented to the screen yet. So we do need to understand that and internalize that. And I'm assuming this kind of should show up in the should show up on the GPU side, as like work and idle. But I think this is such a simple application. Like we're not moving mountains here. This is not a AAA video game. where we're selling, where it's hammering the GPU or anything. We're just simply rotating a triangle, right? So whether we freeze the triangle or not, like in the bigger scheme of things, it's not that big of a deal, right? So it doesn't really even show up right here, but at least on the encoding and the CPU, and then of course the drawable present and presented, we could see that there's a difference on the thread too. But yeah, anyway guys, this instrument is metal trace, and yeah, we could see we could see we could see a bunch of stuff, but nothing too crazy. But I definitely wanted to bring this up just so that we have an idea of what's going on. Thank you for watching. This is guys, if you want to be able to run this stuff on your machine, get the Hello Triangle app, download it, open up the Xcode project, run it. You're gonna probably have to do some, you're gonna have one or two errors, like sign in locally or signing, remote build or whatever. You're gonna have to change it to build locally or something. But you could run this easily if you have a metal capable machine. All you have to do is download the sample code. I have the links down below. Download the sample code. Download Xcode and run it in. Open up the project file, the Xcode project file. Run it. Build and run. Basically, you press the play button, and then it will tell you whatever errors you get, and basically you just run the application, right? Make sure you choose Mac OS as the device that you're running in, and all of that stuff. But I'd love for you guys to follow along and also comment down below, like, subscribe to the channel, tell your friends. Let's build a community and get this stuff going. But yeah, this is Cuda Education. Thank you for watching.